Hello everyone, we have all been there. It's exactly 1 year later that I'm here and recording a video about math. We are doing math, exactly, with same passion, but with difficult and different equations. So today we are going to dive in some problems. For example, you need to calculate nasty equation like, for example, let's write f(x) equals to e to the power of sine x dividing square root of 1 plus x. It seems very difficult, right, to find the final answer. If you stick to the definition, you probably need to find the first derivative, second derivative, third, maybe fourth, and you will mess up in some point, and at the end probably will make a sign error. But there is a better way to solve this type of equations. We can stop doing calculus and start doing algebra again with high-level equations. And today we are covering operations on Taylor expansions in our book section 7.3. Probably if you don't know Taylor expansions, I can put the link of my mate who is explaining Taylor expansions, Taylor series and operations. But let's continue with this part. At the end we are going to learn how to add, multiply, divide, can use Taylor expansions to save hours of work. Before we are going to hack the equations, we need to get permission from the mascots. That's why we are referring to the proposition 7.3 at the book. Let's see.
So, and the proposition 7.5 says that let's take f a b going to real numbers Pn times differentiable at x0, which is the interval a and b. If there exists a polynomial Pn which degrees less than n, such that f of x equals to Pnx plus little o x minus x0 to the power of m. If you don't know what's little o, I'm gonna explain in the next part of our video. So for x going x0, then Pn is a Taylor polynomial which is Tn equals to T f and x0 for order n for the map f at x0. Okay, so let's continue with the examples and I'm returning to the board. See you. Okay then, let's focus on problem hyperbolic sine x. As we know, hyperbolic sine x equals to e to the power of x minus e to the power of minus x dividing 2. So in this part, we just need to calculate, find Taylor expansions of e to the power of x and e to the power of minus x. So, as we know from previous classes, from previous topics, e to the power of x equals to 1 plus x squared plus 2, as it's the 2 factorial, plus x squared dividing 3 factorial, plus blah blah blah, plus x to the power of 2n plus 2 dividing 2n plus 2 factorial, plus little o x to the power of 2n plus 2. So, this is the Taylor expansion of e to the power of x. By the way, little o is the Landau symbol, which means that this part, for example, take this part is always greater than this part. That's why we can even write little o, the biggest, over x squared. We know that this part is bigger than this, that's why we wrote plus little o x squared. This means that there is infinite numbers in the equation, infinite calculations, but coming to one point, it's easier to write like. So, and e to the power of minus x, we'll plug the minus x into the x, then it will be 1 minus x plus x squared dividing 2 minus x squared x to the power of 3 dividing 3 factorial plus blah 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 plus x 2n plus 2 minus x dividing 2n plus 2 factorial and little o x to n plus 2. Okay, and we just need to find the sine hyperbolic sine x, which equals this, and we'll subtract these two, and you see that when we subtract, all even powers are eliminated, and we will only have odd powers, I mean 1, 3, 5, and this will be, if we calculate, 2x plus 2x squared dividing x to the power of 3 dividing 3 factorial, for example, plus 2x to the power of 5 dividing 5 factorial, and blah blah blah. And also dividing, we also need to write little o, let's write. Let's give it right, and I'll add at the end. Dividing 2, then we will have x plus x to the power of 3 dividing 3 factorial plus x to the 5 dividing 5 factorial plus, from subtraction, we'll get plus plus x to the power of 2n plus 1 dividing 2n plus 1 and plus little o x to the power of 2n plus 2. Okay, so this is the Taylor expansion of the hyperbolic sine x. Which in the calculation, hyperbolic sine x and hyperbolic sine x is very difficult for my side to calculate the Taylor expansions, and we made it only using the operations of Taylor expansions. Let's dive into the next. First level, composite functions. So let's look at how can we use Taylor expansions on composite functions. For example, on the 7.11 they asked order 2 the expansion of h of x. H of x equals e to the power of square root of 1 plus x minus 1, right? And the order is 2. So what we have there? We have e to the power of square root of 1 plus x. Let's take this as y, and the equation will be e to the power of y minus 1. We need to find Taylor expansion of e to the power of y. And besides, what's y? 1 square root of 1 plus x. So like that. And let's go. What is the Taylor expansion of square root of 1 plus x? It's 1 minus 1 plus x dividing 2 minus x square dividing 8 plus little o x square as the second order, as you know. And what's y? This one minus 1. And we'll eliminate x over 2 minus x squared over 8 plus little o x squared, right? And then we will use e to the power of y, which is, so let's write it again to make it easier. What's the e to the power of x? 1 plus x squared dividing 2 plus dot 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 plus x to the power of 2n plus 2 dividing 2n plus 2 factorial plus little o x to the power of 2n plus 2, right? But our order is 2, that's why we only take the second order, which is e to the power of x equal 1 plus x squared dividing 2 plus little o x squared. And so we will substitute y with x, so e to the power of y will be 1 plus y squared dividing 2 plus little o y squared. So what's y? E to the power of y. 1 plus x over 2 minus x squared over 8 plus, I'll take orders to make it easier, some easier, plus y squared, which is x over 2 minus x squared over 8 squared. Which is there any like that? Dividing 2 plus little o, and this one it will be x squared. So let's find this. What can we take it there? X over 2, 1 minus x over 4 squared. And never mind, let's take it as it was. So let's calculate this one. It will be x squared dividing 4 minus 2 to x cubed dividing 8 plus x to the power of 4 dividing 64. But as it's order 2, what we'll do? We'll eliminate the powers which is greater than 2. This one and this one. What we have? X squared dividing 4. And 1 plus x over 2 minus x squared dividing 8 plus x squared dividing 2 and 4, which is 8, plus little o x squared, and we eliminate these ones to the power of y. And what we will get? 1 plus x over 2 plus little o x squared. So, as we get the answer, which is the answer of composite function, e to the power of square root of 1 plus x minus 1, which is e to the power of y, which is 1 plus x over 2 plus little o x squared. So this is the answer, which seems maybe difficult than others because it's the composite function, but as you see, I only do the algebraic calculations. There's no calculus in there, there's no differential, there's no differentiative or integrable things that I do, but generally it's easier to use Taylor expansions. So at the end, when you face a complicated limit or function or calculation equation, don't rush to differentiate it. Check if you can build the function from elementary sum, product, or division, or even composite functions using Taylor expansions. So every time try to find the best ways to solve the problems in math or in any part of the life, and work, think smart, not harder. And at the end, I hope that you enjoy from my video. I don't know how many people enjoy from watching math videos if it's not so important for you. And
Also, I hope to get my 5 points from this video. Thank you for watching.